Okay, so for those who are already in the Google Share Drive, I think this is what you will be able to see. Let me share my screen. Okay. Okay, so this is what we can see over here. So for questions 1, what I intend to do is that we are going to discuss it together. We're going to do it together as one group since there's only like 8 of us here. Yeah. So for questions 1 on the HAZOP analysis, I want you to read through this and start working on that. You have about 15 minutes to look at what do you want to do with this heat exchanger. And as given that the heat exchanger is used to heat flammable volatile solvent, and so the temperature of the outlet stream is measured by a thermocouple, and so you may proceed from there. Yeah, so you can put in your solutions in the next tab, process parameter, what are the guide words that you want to use. Since there are 8 of us here, I would suggest every 2 to 3 persons, your group yourself, okay? Every 2 to 3 persons work on one guide word, okay? Process parameter here is definitely the steams coming in, okay? Or the temperatures of the solvent, so you can work on either one, okay? So let me put it this, volatile output temperature. Okay, so you can use on the guide word where the temperature is too high, the temperature is too low, what are the possible causes, etc. If you need more, you can actually extend from this table. Okay, you all have 15 minutes or 20 minutes to work on this. You can unmute yourself to discuss, Hi, I think we are almost done. It's just that the flow rate at the heat exchangers. Okay, which flow rate you are talking about here? You have so many flow rates. You have your volatile flow rate, you have your steam flow rate. So which one are you looking at? Okay, once you get that correction done, then we can start to talk about this Hazard table. This is a simplified version. Okay, so let's take a look at the questions. Yeah, the heat exchangers is used to heat a flammable volatile solvent as shown in this figure. The temperatures of the outlet stream is measured by the thermocouple, and the controller valve manipulates the amount of steam to the heat exchanger to achieve the desired set point temperature. So first we identify the study node of the process, which I believe you have done. Some of you were talking about measuring the temperatures of the volatile solvent at the output and to look at what went wrong, and a lot of the causes and all that are linked back to the same system, which is correct. And the other one was talking about the flow rate of the steam, which is this line. Yeah, this condensate, steam to condensate line here. Okay, let's see if I can draw something. Okay, never mind. So perform a hazard study on the intention of hop solvent from the heat exchanger, recommend possible modifications to improve the safety of the process. So let's see what do we have here. Okay, so volatile output temperatures, the guide's high. What could cause high volatile output temperature? So malfunctions of thermocouple, steam stream flow rate too high, steam blocking. Okay, this last one that you all type in is quite interesting. So if let's say the steam is being blocked in there, how does it make the flow rate, how does it make the temperatures go higher because the steam is not flowing? Anyone? Yeah, anyone? Like this last sentence here is a bit interesting. Oops, not this. Oof. But if your steams cannot flow out, then there will be no steam coming in, right? Because it's one pipe. Once blocked, it will block the whole thing. Means your steam amount is there's only so much heat transfer can be done. Yeah, I think this the last one doesn't. That one may be for low temperature. Yes, for high temperature, I know what you're trying to say. Is like if let's say it gets stuck in there, and therefore it causes it to not flowing that heat build up. But it doesn't work that way because this is a steam flow. Yeah, so the moment it stops flowing, there's only so much energy stored in there. But the steam, high flow rate due to incoming pump failure or incoming compressor failure or incoming valve or whatsoever that causes it to go high flow rate that bring in more energy that might cause your output temperatures to be higher. Okay, so the possible consequences, yes, I would suggest you avoid using the word explosions, but we use it as a runaway situation. yeah, in the safety. Yeah, because it's not necessary you go to explosion, but sometimes it can just be hiccups, runaway situations. Yeah, so not necessarily it leads to explosion. So okay, situations due to high temperature. Right, next unit operation. Okay, so air pressure occurs, more solvent change to vapor. Yes, that is another possibility. Good. So actions required. First, of course, you have to check on your control system to see what happened and to reduce your steam flow rate. Okay. Install high temperature alarm. That's a good one. Any other suggestions? Remember when we study the relief system in chapter 9 in week 3 talks about all the relief valves must be installed at the output of the heat up chemical and also at the input of the heat stream. Yeah, so means you need a relief systems at this volatile output pipes in case as any runaway like overpressure caused by the solvent changing to vapors and all that, we have a release system in place to reduce the pressure build up in the system, in the pipe. Okay, so for low temperatures, inlet steam blocking, heat expansion due to steam. What is this? Okay, I got what you mean here. How would this solve the steam blocking? Apply flow rate indicator, because this is just to put in another check valve in there. So, but how do you solve this issue? What causes it to block? Impurities or valves close or what? That's what you want to solve. Anyone? Oh, you all have been very quiet today. Please. If you have nothing to add, then I'll stop there, yeah? Until you have something to add, then we come back to this one, because sometimes you may want to really think about like, what do you want to do? Hands-on analysis is not to say like really within 15 minutes you can finish a good hands-on. Sometimes it takes times for you to really think through like, what do you want to do next? Okay, so these working files will be open. So anytime when you have an aha moments that you have an answer for that, you just feel free to come back and add it in. Okay, so this will help you in your assignment, because the assignments definitely you want to do a good heads-up analysis in there. That's where this is where you can refer to. What we are having here is a I would say a simplified versions of heads-up, because there are more columns in there. But what we are going to discuss here is the gist of like what needs to be done, what are the important parameters that needed to be in these tools that we use. Okay, I see more and more informations coming in, which is good. Okay, okay, thank you. So when there is no output temperature shown, what does that mean? There's only two things. Either your display unit is at 40, means everything go blank, or your thermocouple has been disconnected, or 40. So that's where there's no reading shown at all. So in that case, the consequences is you won't be able to know what is the actual temperatures, if it's too high, if it's too low, and this is actually very dangerous. So immediate actions is to replace the display unit, whichever 40 unit, be it the thermocouple or the temperature display unit. And you may also want to consider to have a scheduled maintenance check every 6 months, just to make sure things are intact. But this one, if let's say you see that suddenly you wake up, you go to the office and you look at the temperatures, it's not showing anything, you know, immediate actions need to be taken. Okay, so I think that's about it for HAZOP. Just we work on 3 guide words only. But in your assignment 1, in your case study, you may need to have more guide word than just 3. Sometimes you may have, if let's say you're talking about flow rate, or if you're talking about the flow of input chemicals. So sometimes you may have reverse flow. What causes the reverse flow? What causes the back pressure? Okay. And also you may have some things like the streams instead of stream A coming in as well as stream B is coming in at the same time. So what happens? What went wrong there? Okay, so flow rate of steams, I'm not going to go into that because it's sort of repeat of what we just said on the first 3. It's quite similar. So this is how we build on our HAZOP table. And bear in mind, sometimes HAZOP table can go into very detailed to the extent that your HAZOP table may be like 10, 20, 30 pages. It's okay. So my suggestions is you work on it on an Excel spreadsheet instead of a Word spreadsheets like this. Yeah. So when you work on Excel, you can just expand it and expand it and expand it further. Okay. So any questions so far regarding HAZOP? Class? Any questions? Because this is very important for your assignment 1. Yeah, we are preparing you for your assignment 1. And also, for those of you who has attend your internship last year or early this year, you have known that some company, they also have this HAZOP practice. A bit, are you involved in the HAZOP analysis like what we did here, or you are the user of the outcome, like the actions taken? Okay, do this checklist, do this, do this. You know, as an engineers, HAZOPs will be part of our work in the future. So keep all this data in here, especially this chapter, yeah, because there are some guide words, there are some keywords that you will in the future refer to. Okay, so now we have other questions. We have questions 2 to questions 5. So we have other 4 questions that's purely on discussions. So what I'm going to do is I'm going to break you all into different groups. So if you're in group 2, then you go to questions 2, group 3 in question 3, things like that. Yeah, give me a moment. Let me split you all into different groups. Okay, so I'm going to put you into all your breakout rooms. So once you're in the room, you start to discuss each room about 2 to 3 people. Yeah, so just discuss what you want to, what do you plan to do. John, we want to go to your classes, to your room. Hi, the two of you working on question 4, yeah?
Oh, okay.
Oh, it's question 4. Okay.
Okay.
4. Yes, yes. So I think you all has accidentally go to other questions.
Okay.
Okay, yeah. So this is quite an easy one.
Okay.
Hi, how are you doing? I thought there are 3 over here. It's just left 2 of you.
Yeah.
Okay. You all are working on question 2, right?
Yes.
Okay, good. So we'll just continue to work on that. Thank you.
Okay. Okay.
Hi, how's this group doing? You're working on question 3, right?
Yeah, correct, miss.
Okay, so just want to make sure because just now there's one group working on the different questions. Okay, any issue? Because I see that you all haven't typed in anything yet.
Possible multiplication.
Come again?
No, miss, I don't understand. What does the sentence? The scale indicates 0 to 100% for temperature range.
Yeah, so you figure it out and then you would then see what went wrong with these questions. What went wrong over here?
Okay.
Yeah. Hi. How's question 5 coming along?
We are still thinking.
Yeah, this is just asking you to do a simple design change. So
Yeah.
you can actually draw if you want to.
We try to.
Yeah, you
Okay.
can draw on the piece of paper, snapshot, and then put it up.
Okay.
Yeah.
So for question 2, the question is, your manufacturing plant has purchased a number of robots to facilitate production. What are the main hazards associated with robots, and what are some effective safeguards against these hazards? The first hazard that we come up with is the error in the control system, whereby there is a fault in the control system which may lead to erratic and unpredictable behaviors of the robot. One safeguard on this is to conduct regular maintenance on the control system. And the second hazard that we found was the mechanical failure. And this is where like some parts of the robots becomes faulty or like breaks down or something like that. And then for this, it would depend on the specific components on the robot, and we will have to conduct further risk assessment like the depending on the parts of the robots. And then for the third hazards would be electric short. So for this, usually the electric short would happen during like maintenance work or like stuff like that. So one way to combat this is to practice a lockout slash tagout system when performing maintenance work, where the energy from the robot is like closed when doing maintenance work, so that the robot doesn't accidentally start or power up and then causes electric shock, which would lead to electric shock. And the fourth hazard would be that the robot has limited thinking power. So for certain certain operations, it would need human actions during certain steps for decision making. And the fifth hazard would be improper installation. For this, we would have to ensure that all the workers are trained in properly and correctly installing and maintaining the robots. So the fourth one would be sabotage. Robots are very prone to hack and due to weak cybersecurity and all that. So for this, we will have to install firewalls and frequently update all the firmwares inside that. That's all. Thank you.
Thank you very much. That's actually a very good answer. Any questions from the floor to this group? If you want to ask them anything about their answers and all that. Okay, all good. So in that case, then thank you very much. So we go to the next questions. Question 3. Can we have someone from the question 3 group to present?
Yeah, please. So let me go. Yeah, the scenario that we thought the scenario was that the temperature controller was not calibrated for the temperature, but for the percentage. But we are not sure whether if this is how the system works. So, but the operator initially set it at 60% for 60% of 200 degrees Celsius, which was 130 degrees Celsius. So which means the temperature is double the operating temperature because the operator was told to maintain the operating temperature at 60 degrees Celsius. So from the indicator, the operator wouldn't realize that the operating temperature is actually doubled, which caused an overpressurized reactor to discharge hot liquid and injure the operator. So the only possible modification that we can think of without having to incur additional costs was to recalibrate the temperature controller so that the new scale indicates 0 to 100% for the temperature range of 0 to approximately 67 degrees Celsius, such that the operating temperature at 60 is shown as 90% on the indicator. That way, the operator will have to maintain the reactor operating temperature at 90%. If in any case where the operating temperature exceeds 60 degrees Celsius, meaning the indicator will show more than 90%, then the operator will be alarmed and proceed to shut down the reactor before it reaches 100% to prevent any accidents from happening.
Okay, thank you very much. So when they set it to 60, it means it's actually 120 degrees Celsius.
Yeah, because in the question it says he set the point of the temperature controller at 60, but it wasn't clearly indicated whether it was degrees Celsius or percentage. But the next sentence states that the scale actually indicates percentage, and the previous, and if you link back to the previous sentence, it says he set the point of temperature controller at 60, which means 60%.
Okay, so in that case, right, I have another proposal.
Okay.
A slightly different proposal. Instead of calibrate it, what if I put a sticker and give a new set of instructions to the operator to just set it at 30?
That would be easier.
or as a process engineer, that's what I will do. I just go and get some sticker or a marker pen. At the 30% mark, I'm just going to draw a thick line there and say set here. That's it. It's no calibrations, nothing.
Yeah, it's actually, I see your point, Miss, because I think it's better to have a larger temperature range because it would be quite unreasonable to just limit the temperature to 67 degrees Celsius.
Yeah, I don't know. It's hard to do the calibration because when you do calibrations means that if it's off, then you have to redo it again and all that. So it'll be easier to just set it according to what we want.
Yeah, correct.
And instead of telling our operator, oh, you have to do 60% or 60 degree or anything, no, we just tell them, whatever you do, look at this line, go there.
Okay.
That's my proposal. That's what I would do. But what you suggest is doable also. Honestly speaking, what you suggest is doable. Because as engineer, there's no right or wrong way of doing things, you see. So it's just that sometimes you may come up with an idea that is easier, or sometimes you may come up with an idea that's practical, or sometimes you may come up with an idea like your idea is really practical, because then 90% is easier to really maintain it.
Okay, understood.
Yeah, so it's yeah, so there's no wrong answer. Even your answer is correct. It's just that I'm proposing a different answer so that everyone here can have a seat, have a view of like, hey, yeah, oh, I can do this, and also I can do this. It's not
Yeah.
necessarily fixed
Yeah,
in
with a
one
different
way.
perspective.
Yes, that's my point. Thank you so much. Any other questions or any other suggestions? Now we open up to the floor. It's like brainstorming time. What would you do? Okay, everyone seems to be very quiet.
Because we are
Okay.
registering for the vaccine.
Oh, you're registered for vaccine.
Yeah, still registering.
All of you? Okay, all the best. Okay, so now the next questions. Can I have group 4 or for the questions 4 to come and discuss your answer?
Hello.
Hi.
So basically, liquid levels in storage tanks are quickly determined by measuring the pressure at the bottom of the tank. Then in one tank, the material is changed, and then there was an overflow. So basically, because since the pressure is a function of the density of the liquid, and then the pressure at the bottom is force per unit area, and then the mass is related to the density. So when the density of like the probably when the probably when the material stored in the tank, it overflowed because the density decreased, which then made the pressure increase as well as the volume. And since probably the storage tank was supposed to be stored for a different material, when that material was stored in, it wasn't suitable with the storage tank, causing an overflow.
I wouldn't say it's not suitable. Okay, I'm gonna
Okay.
debate here. It's just that because the material change, and when you have a change in material, sometimes that happens in manufacturing. When we have a better or a cleaner or a greener materials instead of those toxic materials, you may want to think of, oh, I don't want to use this anymore because it's toxic, because it's volatile, because it's not stable, because of whatever reasons, or because it's cheaper. So sometimes engineers get to make the decisions to say, I want to change the chemical. But sometimes when we change chemicals, there are other factors that we may have overlooked. For instance, in this case, what happened is that they changed the material, then the storage tank overflow. The material in the storage tank overflow. Just because of the simple things, because the material change, the density change. And the density change because this height of the liquid is measured by using pressure, the very old way of measuring the liquid level. So in that case, if let's say you are not given any budgets to change the liquid sensors or anything, the easiest way to do that is to recalibrate the pressure sensors down there, just to fit into the new storage, new chemicals that you want to use. Okay, so what Ileana's gave, the answer is correct. The pressure, the density changes. That is why the material overflow. Any questions over here, or any other suggestions other than calibrations, or any other way to explain the scenario? Anyone? Calling 1, calling 2. calling 3. Okay. Thank you very much. In that case, then we go to the next questions. Okay. Oh, questions 5. Can I have someone to present? Thank you.
Hello. Yeah, I will present question 5. So for question 5 is a sump tank designed to collect the processed fluids. The level controller and the pump ensure that the sump level is maintained below a maximum height. So to suggest a simpler system for this sump tank. So our suggestion is to prevent the overflowing of fluids in the sump. The outlet pipe is installed at the maximum height of the sump instead of using level control and pump. So the mechanism of this is like a sink that installed in the bathroom or in the kitchen.
Okay, thank you very much. This is where, remember in chapter 1, we talk about the 4 ways of what we call as inherent safety, to simplify things, to minimize things, to eliminate if it's too dangerous and all that. So this is basically one of the concepts, to simplify it. Instead of using a level controller, using a pump to maintain the level in the sump, just use an outlet. We call the overflow outlet, like what they draw in here in the red pipe. This indicates the pipes, the overflow pipes. So once you put it there, anything's overflow, anything's higher than that, you don't need to maintain the pump, you don't need to maintain the level controller. It will just flow out. So make sure it is connected to one of your containment tank, so that whatever overflows go in there, and you treat it before you discard them. That's as simple as that. So any questions so far? So for this chapter, basically what we are going to sum up here is that as an engineer, whenever you go into a manufacturing a process, keep your eyes open. You will notice there's a lots of improvements that can be done. A lot of simplifications, modifications can be done. So it's your job to make life easier for the people who use it. If you notice that all these questions today, we talk about robotify the manufacturing is in questions too. We talk about simplifying the controller, like the controllers is old controller, so you can't change it. Then how do you want to make operators' life easier without allowing them to make further mistake? And questions 4 talk about simple modifications of, if you change your process, what are the things that you need to look at? And question 5 is just simplify the sump tank. Okay, any other questions so far? So I believe with this, right, you can start with your assignment 1 ready, because that covers quite a huge chunk of your assignment 1, to talk about like taking actions. If you notice that, hey, this one doesn't work here, what do I do? So we have already given you some ideas of how to simplify things. Okay, so with that, I'll see you on next Wednesday for our next tutorial. Yeah, next week we are going to talk about fire and explosion. So it will be there are questions given, then we're just going to solve it. Any questions so far?
Yeah,
Yes.
Miss, I have a question on the assignment.
Yes.
Miss, for the third part, right, for the risk assessment part, you mentioned that we are to compare the outcome to Malaysia. Actually, the risk assessment, we will do it on the topic that we found, is it? Or we have to...
Yes, the risk assessment, this is part of it. This one is hazard analysis. You can use this one, or you can use event 3, fault 3, which is, I think, in the next 2 chapters. And
Okay.
also, but I already opened all the chapters so that you can start viewing that chapters first. Okay, and then you can also, if let's say the factories or the case that you took up is something to deal with chemical storage explosions, you may want to use some of the information over there and recalculate how much chemical that they actually store and how much is allowed. So these are all the calculations that you can use in that section.
Oh, okay, okay. And then you mentioned that we have to compare the outcome to Malaysia's manufacturing culture. So how
Yes,
do we do
so
that?
it is like, for example, if let's say you are talking about the Tianjin explosion case, I just give an
Okay.
example. So they have stored excessive explosions chemical underground, which is like walking distance to an apartment.
Mm.
Yeah. So if let's say you know things like that happen, how do you want to prevent things like this happening in Malaysia? What can DOSH do? These are the suggestions that we bring it back to home and say, okay, so what our government has done, they have
Right.
divided, this is industrial zone, this is the non-industrial zone, this is residential zone. They call it the green zone and the brown zone. And so if you notice also, currently the government is pulling out the industry from Sungai Way area. That is very near to where we are, the Western Digital areas. All the industrial, they are slowly pulling out. Yeah, because of the safety issues, partly because of safety. It's too near to residential area. It's too near to the business center. So any things happens, touch wood, any explosions happens, chemicals that they store them might cause a cradle in the whole PJS area. So that's the severity of things. That's where I want you to study those cases. That is obviously not in Malaysia. Wherever cases you pick up, those are big cases, and then you bring it back close to home and say, okay, in that case, what is your suggestions? If you look at, oh, we have this in this free trade zone very near to residential area, what should we do? What is your suggestion? Some of your good suggestions, because you're going to write it in a paper form, those who are written very well, I have to be honest with you, I'm going to publish that paper with your name on it to as information sharing, because this is your work.
Oh, okay, I see.
Okay.
Okay, thank you, Miss.
Yeah. So do a good work over there, yeah? Any other questions regarding your assignment? That's why you notice that your assignment is in the paper publications format. You have introductions, you have the risk assessment that goes straight into how we compare it. Okay, you can, if let's say you have any questions, you can contact me via WhatsApp, you can message me personally, or you can email me. Or if you need a consultation, I will just let me know, then we can schedule a 1-to-1 or even 1-to-3 sessions with you regarding your assignment. Okay, if not, then I'll see you next week, same time. And then the following weeks, then we will start to schedule for your assignment presentations. I think we will start week 12 onwards for assignment, the presentations. Okay, thank you very much, and enjoy the rest of your holiday today. Thank you. See ya.
Okay,
Bye-bye.
Thank you, Miss.
Thank you, Miss.